If you take pi and multiply it by itself, you get approximately 9.87, which happens to be very close to the average gravity on Earth. This weird coincidence isn't random. It traces back to how we used pendulums to define measurements. This is about the seconds pendulum used in clocks, a weight on a string that takes exactly 2 seconds to sway away and back to its starting position. Its period is defined as 2 pi square L over G, and since the period in this case is 2 seconds, we can plug that in. When we simplify and square both sides, we get G equals pi squared L. Now if we assume the pendulum's length is exactly 1 meter, we get G equals pi squared, which is approximately 9.87. This is why scientists in the late 18th century almost defined the meter as the length of a second's pendulum, but they didn't for a big reason. Gravity isn't constant. It varies slightly depending on where you are on Earth. Pi, on the other hand, is a pure mathematical constant. It comes from infinite series or circle properties in a flat space. It has nothing to do with real-world physics. A warped space near a big star would have a different pi, but calling it pi would be wrong. Pi only exists in the math realm. That's why today we define a meter using light. 1 meter is the distance light travels in about 3.34 nanoseconds. No gravity, no pendulums, just a universal constant.